video we will learn about the extraction of aluminium. So aluminium is the most abundant metal on the earth crust. That symbol is A and small l. Atomic mass is 27, atomic number is 13 and electronic configuration is 283. That means it has 3 electrons in the outermost cell and it belongs to third period and group 30. Right. Now aluminium is basically a quite reactive metal, therefore it does not occur in the free state in the nature. Therefore it occurs in nature as mica, sometimes bauxite, that is aluminum oxide dot 2H2O, and cryolite sometimes, that is sodium, aluminium and fluoride in a combined form. Here bauxite is the only economical workable ore of aluminium from which aluminium is extracted. Now the metallurgy of aluminium involves the following step. The first step is the concentration or purification of bauxite ore, that is known as the Bayer's process, by which we extract the more ore particles or the aluminium ore particles from the bauxite ore. So what happens in this process? So bauxite is normally contain about 30% of aluminium oxide, that is Al2O3, and rest are the impurities like iron oxide, silicon oxide, titanium oxide, etc. Here bauxite is finely grinded and heated to remove the volatile impurities. Also it is then heated with moderately concentrated caustic soda, that is known as sodium hydroxide, also that is NaOH solution, at 140 to 240 degrees Celsius under pressure about 35 atmosphere, and that's why the bauxite goes into the solution as sodium meta-aluminate. Here you can see after reaction with NaOH of bauxite ore, it get converted into sodium aluminate and release the water molecules here. And sodium aluminate is basically sodium, aluminium and oxygen combined in a form. Now talking about high pressure basically is required to prevent any other hydroxides to get reacted in the reaction from boiling off, right? And the impurities in the bauxite remains undissolved solid here. Now the other metal oxides present do not react with sodium hydroxide. Only the aluminum oxide react with the sodium hydroxide, that is NaOH, or the caustic soda we say earlier. Though some silicon dioxide reacts to form sodium aluminosilicate, which precipitated out through the reaction. All these solid forms are red mud and are separated from the solution by simple filtration of the substance. Now here the solution that contains the sodium meta-aluminate is cooled to 50 degrees Celsius and agitated with air, and somehow previously produced aluminium hydroxide is also added as a seed. This provides something for the new aluminum hydroxide to precipitate around. So here when this sodium aluminate is reacted with air and water, it releases aluminum hydroxide as precipitates, that means in solid form, and the NaOH is released here, and the precipitated out aluminum hydroxide is removed by simple filtration, and the precipitates of aluminum oxide is then ignited to pure form. So here what happens, if we heat this aluminum hydroxide to 1100 degrees Celsius, it directly gets converted into aluminium oxide. Now what happens to this aluminium oxide, known as also alumina? So we simply electrolyze, or we simply do the electrolytic reduction of the molten alumina, that is Al2O3, that is also known as the Hall-Herold's process. So in this process the aluminum oxide is very stable compound which melts at 2050 degrees Celsius, and here it is not easily reduced by the common reducing agents such as carbon, hydrogen or carbon monoxide. Therefore aluminum is obtained from the aluminum oxide by electrolytic reduction. So what happens in the electrolyte? So it is a mixture of molten purified alumina, that is Al2O3, cryolite, that is Na3Alf6 in 60% proportion, and the fluorspar, that is calcium fluoride in 20% ratio. Now powdered coke is sprinkled over the surface of the electrolyte. Here what happens, first the molten cryolite act as a solvent for the molten alumina. Also the fluorspar lowers the melting point and increase the fluidity of the metal, and the molten alumina is a poor conductor of electricity, but the melt contains alumina, cryolite and fluorspar is good conductor of electricity for the electrolytic reduction. Now what happens in the electrolytic cell? So here the electrolysis is carried out at 1000 degrees Celsius in the carbon lined steel vessel, right, serve as cathode, and the anode is a line of graphite rod which helps in basically the oxidation of carbon, or basically in the reduction of oxygen released during the reaction. Now here you can see the carbon lining that is act as a cathode in the chamber. This is the electrolytic extraction of aluminium from the alumina. So here you can see other graphite rod that act as anode, and here is the carbon lining that act as the cathode. So what happens here? First, the temperature is very important. So electrolysis is carried out at a very low voltage of around 5 to 6 volts, but at a very huge current density, that is around 1 lakh amperes. Here the heating effect of the large current keeps the temperature of to melt at 1000 degrees Celsius. So here the reaction is what happens. So first the molten aluminium oxide get converted into aluminium cation, aluminium 3 positive cation, and oxygen 2 negative anion. Then this molten cryolite, that is Na3AlF6, get converted into Na positive, Al3 positive, and F negative anion. Then this fluorspar, that is CaF2, calcium fluoride, get converted into Ca2 positive ion and fluorine negative ion. Now what happens at the cathode? So at the cathode, this aluminium that is released during the reaction in form of cation accepts 3 electron and become aluminium metal in liquid form or the molten form. Now here recurrent drain of molten aluminium and continual addition of alumina allows uninterrupted operation of the electrolytic cell. So this is how we get the aluminium. Now talking about what happens next. So at the anode, what happens? Series of products are formed. So first the oxygen that is made at the anode first get converted into oxygen gas, and then this oxygen gas combines with the carbon of the anode, because carbon is present at the anode as the anode is made up of graphite, and this forms the carbon dioxide gas here at the anode. Now what are the major points here to note? First, a number of graphite electrodes are used instead of a single electrode because smaller distance between the line of the electrode decreases the resistance caused by the electrolyte melts, and this increases the efficiency of the process. Also, the graphite electrode, that is basically anode, get burnt up during the operation of the cell and therefore are frequently changed, because we know that here the carbon of this anode or graphite is used for making carbon dioxide during the reaction. Now the layer of powdered coke on the surface of the electrolyte serve to prevent the heat loss by radiation and burning of graphite anode rod. Right? Now here the aluminium metal thus produced in 99% pure. Now talking about the refining of aluminium, that is known as the Hoops process. So what happens in the Hoops process? So first the aluminium is further refined electrolytically by the Hoops method, and the process is carried out in an electrolytic cell which contains three layers. The bottom layer of molten impure aluminium that is extracted from this Hall-Herold's process, and the top layer is of pure molten aluminium, and the middle layer consists of a mixture of molten fluorides of sodium, barium, impure aluminium that serve as an electrolyte. Here you can see this is the aperture, or this is the system for our Hoops process, where we have the molten impure aluminum at the bottom and the top layer is of pure aluminium. Then we have the graphite cathodes here, right? And then we have the funnel for pouring the impure aluminium at the bottom, and the middle is act as a electrolyte here. This is the middle, right? That has the mixture of fluorides of sodium, barium, and aluminium. So what happens here is a set of graphite rod dipped into pure molten aluminium. Here you can see here the pure aluminium has the graphite rods dipped into it. During electrolysis, the Al3 positive ion forms the middle layer, migrate to the upper layer where they are reduced to aluminium. So what happens? The aluminium 3 positive will move from the lower molten impure aluminium layer to the upper layer and get deposit on this graphite layer, like here, like this. Okay, and what will be the process? At the cathode, the aluminium get converted into its metallic form from the ionic form. At the anode, the aluminium converts into the aluminium cation and by losing 3 electrons. Now here, after this refining, the aluminium become 99.99% pure. Now here you can see the flow chart of extraction of aluminium. First, the aluminium ore, that is the bauxite ore, purification of bauxite by Bayer's process by using NaOH, that is caustic soda, and hitting the reaction at different temperatures, first on 150 degrees Celsius, then 50 degrees Celsius, and then at 1000 degrees Celsius. Then the electrolytic reduction of alumina that is obtained from this purification of bauxite, and this is known as the Hall-Herold's process, in which we get the extracted aluminium that is 99% pure. Then this 99% aluminium is then again refined by Hooft's method, by which we get the purest aluminium that is 99.99% pure. So I hope this topic is now clear to you. Thank you.